Welcome to Ask and Learn.
For fluid pressure, we are given a tank, and this tank will be filled with water at the top. So we are to determine the force on ABDC, this rectangular plate, and BEFD, this rectangular plate. So first, let's draw the cross-section of the tank. So we have a slanted line and a vertical line. So we have this as point A, point B, and point E. This is 3 feet wide, and this is 4 feet high, while this is 6 feet high. And we have the pressure acting on it linearly. Let's call this as pressure 1 and the bottom as pressure 2. So for plate ABDC, we have two forces acting on it. We have a horizontal one and a vertical one. The vertical one is due to the liquid displaced by the plate. So let's call this as Fy1 and this one as Fx1. So Fy1 is equals to 80 times the volume displaced, and Fx1 is equals to 1/2 of the pressure 1 multiplied by 4 times 12. So for Fy1, the volume is 1/2 of base times height times 12, which is 72 cubic feet. So our Fy1 is equals to 80 times 72, which is 5.76 kips. And for Fx1, pressure 1 is equals to 80 times 4, which is 320 pounds per square foot. So we have Fx1 is equals to 7.68 kips. So the force acting on ABDC is equals to the square root of 5.76 squared plus 7.68 squared, which is equals to 9.6 kips. And for BEFD, we have this horizontal hydrostatic force on it. Let's call it as Fx2. So our Fx2 is equals to 1/2 of pressure 1 plus pressure 2 multiplied by 6 times 12. And we have pressure 1, and let's solve for pressure 2. So pressure 2 is equals to 80 times 10, which is 800 pounds per square foot. So we have Fx2 is equals to 40.32 kips, and this is the force acting on BEFD.